All right. So in today's class, we are studying modern periodic law and modern periodic table. So yes, in today's group, I have already shared the document. Did you check it? Okay, let me share the screen. Okay, I'm sharing the screen. Let's discuss. So every day, what we have studied, we have to. My voice is not coming. Wait a minute. Now it's not coming. Might be. It's quite slow, isn't it? I will say a bit slowly. All right. I will say a bit slowly so that it will be easy to hear. Okay. Did you see something over there on the screen? Did you see or not? Okay, students. What is given? Modern periodic table. All right. So listen now. D.I. Mendeleev, he gave the law and he prepared the periodic table, but there were many demerits. There were many problems. So to correct that problems and modify the modify the periodic table, one scientist tried a lot. And what was the name of that scientist? Henry Moseley. Henry Moseley. Okay, what are they spelling? Henry. Henry Moseley. So I'm just circling it. Henry Moseley from England. He gave one law and arranged the elements. And the law which was given by him was called Moseley's law or modern periodic law. What is it called? Modern periodic law. So, and what does modern periodic law state? Modern periodic law states that, just you check it here, the physical and the chemical properties of elements are the periodic functions of their atomic numbers. Students, what is the difference in Mendeleev's periodic law and modern periodic law? There is difference of only one word. In Mendeleev's periodic law, it is given the physical and chemical properties of the elements are the periodic functions of their atomic masses. Instead of this number, there was masses. Here is number, isn't it? But in modern periodic law, there is number. So if you remember Mendeleev's periodic law, slightly you can change one word and say modern periodic law. The difference is mass and numbers. And what is the definition of modern periodic table? The definition of modern periodic table is given over here. Just check it. The chart or table that is obtained That's right. Okay, listen. If you have to write or state Mendeleev's periodic table, in that case you have to write here according to, in place of weight, you have to write number. Sorry, in case of atomic number, you have to write atomic mass. What you mentioned there? Atomic mass. So there is slight difference, and it comes the difference of Mendeleev's periodic law, Mendeleev's periodic table, modern periodic law, and modern periodic table. Okay, students. Now what do? We will be discussing advantages of modern periodic table. So how many advantages are given here? Can you see? 8 are there. Students, I hope whatever we are discussing, you are writing. You have to write as soon as possible so that it will be easy. And don't make anything over there in the screen. So please, so only the person who is explaining will make. Otherwise, it will be mess. Okay, please don't try that one. Students, now will be discussing advantages. What is the first advantage? The wrong position of some elements like argon and potassium, cobalt and nickel due to atomic weights has been solved. Why solved? Because Moseley arranged the elements according to atomic number. Yes or no? So elements with less atomic number comes first and more atomic number comes second. So problem solved. Now advantage number 2. Will you read? Who is going to read this? One of you can read. Okay.
The isotopes of the same element have the same atomic numbers, therefore they find the same position in the modern periodic table.
Good. In yesterday's class, we discussed that hydrogen, carbon, chlorine, uranium, these elements have isotopes. Isotopes means they have got different atoms with different atomic weight. So, what is the problem here? Mendeleev arranged according to weight. So, it was difficult for him to place. Moseley arranged the elements according to atomic number. So, all the isotopes have same atomic number. So, they are kept in one group. No problem. Problem of isotope also solved. Now, what is the third point? Will you read?
The position of hydrogen in the periodic table has not been yet solved completely due to its characteristics of group 1 and group 17. Hydrogen is placed above the alkali metals in the group AI because of the resemblance in their electronic configuration. However, the hydrogen is not regarded as alkali metal. This makes hydrogen a unique element.
Okay. In Mendeleev's periodic table, the position of hydrogen was not clear. In modern periodic table also, the position of hydrogen is not clear because it is kept with metals. Though it is non-metal, why is it kept in metals of group 1A? Because its electronic configuration, distribution of electrons is similar to alkali metals. So, there is only one element in the periodic table which has unique characteristics, that is hydrogen. Still, the position of hydrogen is not clear, we have to remember, though it is kept in which group 1A. Now, advantage number 4.
The groups of the modern periodic table are divided into subgroups A and B and treated as separate group A and group B because the element of group A differ in properties from the element of group B. It makes the study of elements specific and easier, but nowadays the groups are numbered continuously from 1 to 18.
Good. Okay, students, now I'm going to show you the groups A and B. Afterwards, we will be discussing. Okay, look at here. Now, in next document, I'm going to show you periodic table. Look at here. This is periodic table. Can you see in the screen?
Yes, sir.
All right, students. So, first of all, here is 1A. I'll just mark. Here, this is 1A. I have just drawn. What is this? 1A. Here is 2A. Here is 3A. Are you just observing or not? Look at the screen. 4A, 5A, 6A. Sorry? No, it is coming. Why not? 7A. Can you see?
Yes, sir.
And here is 8A. Okay, I have just marked here 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Did you see?
Yes, sir.
These are subgroup A elements. Now, I'm going to show you 1B. 1B. Do you see here 1B, 2B? I'm just ticking. 3B, 4B, 5B, 6B, 7B, and these all are 8B. Okay. So in this modern periodic table, they are divided into, elements are divided into subgroup A and subgroup B. So, and listen, the elements of subgroup A possess one type of characteristics. The elements of subgroup B contain next type of characteristic. The characteristics are also different. Okay, so that is the advantage of modern periodic table. Who prepared modern periodic table? Students, who prepared modern periodic table? Henry Moseley. No, Mendeleev prepared Mendeleev's periodic table. And modern periodic table is made by Henry Moseley. Okay, students, now number 5. Will you read number 5? Okay. The elements of group 8 or 18 of Mendeleev's periodic table, iron, cobalt, and nickel, are placed between group 2A, 2 and 3A as a subgroup B, because it is made now here subgroup B. Now next advantage is it separates metals from non-metals. So in modern periodic table, metals and non-metals are kept separately, not in the same group. And number 7. Okay, representative means they have got fixed characteristics. Transition means they possess dual, two type of characteristics. That's why the elements are separated. So I said subgroup A and subgroup B. Subgroup A means they are representative elements. Subgroup B means they are transition. Okay, they are transition elements. Now question number, advantage number 8. Transition means they possess dual, two type of characteristics, not fixed characteristics. For example, let me show you in this chart. Here are some elements. Can you see the elements of group 1A, 2A? 1A is here, just see here. These are 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. These are called representative elements. What are they? Representative elements. And here in the representative elements, they possess fixed characteristics. But these elements, which I have circled, these only, they are called transition elements. Because their characteristics are little bit different than others. And while going from left to right, we have to pass from them. Have you heard about transit? For example, I have to go to Australia. Air transit. I suppose I have to go to Australia. So from Nepal directly we cannot go to Australia. Either the plane go and stay in Singapore and then it goes to Australia, or here to Hong Kong and then to Australia, isn't it? So those places are transit. Here also, we are going from left to right, isn't it? So while going from left to right, we must pass from this middle one. Without going from them, we cannot reach right hand side. That's why these elements are called, what do you call them? Transition elements. Elements of group 1A are representative. Elements of group 1B or B are transition elements. Okay. Now students, what is given here? Number 8. Who is going to read? In Mendeleev's periodic table, There are
8 groups. So it was a compulsion to keep alkali metals, and from there not seeing, sir, what is.
oh no, to keep alkali metals and coinage metals in the same cell. One.
But the modern periodic table, the reactive alkali metals are placed in a group IA, while the less reactive coinage metals Cu, Ag, and Au are placed in a group IB/11.
1B or 11, isn't it? So, one thing we have to keep in mind, modern periodic table is much more advanced than Mendeleev's periodic table, right?
Yes, sir.
Because Mendeleev divided the elements and he kept only 63 elements, but modern periodic table contains 118 elements, and metals and non-metals are kept separately. Elements with similar characteristics are kept in same group, otherwise they are separated. Yes or no? And isotopes are kept in the same group. These are advantages must be set in mind. Understood or not? Okay. Now students, I'm going to share the screen of modern periodic table. So what is there in modern periodic table, that will be discussed. You just check it out. So modern periodic table is much more advanced than Mendeleev's periodic table. So what is given here, let me share. Students are taking part very actively. This is good news. And what you have to do,
Yes, sir.
you have to make note of the thing given to you so that it will be easy later on when we begin our regular class. Then I'm going to check your note.
Yes, sir.
It must be up to date. Okay, students, look at here. Did you see something in the screen? Did you see?
Yes, sir.
Okay,
Yes, sir.
students, I will just point out and then show you. So what is given there? First of all, the periodic table of elements is given here, right? And it's given you a period. Did you see a period? How many periods are there? 7. 1, 2, 3, 4, 5, 6, 7 are there, right? Third period, fourth period, fifth period, sixth period, and seventh period. Okay. And these horizontal rows are called periods. Horizontal rows are called periods. Yeah, these are the periods. And okay, let me rub out these periods. Let me rub out these periods. And now students, look at here. I'm going to show you the groups. I'm going vertically down. This one, this. Can you see in the screen? Can you see the screen or not? So I'm just drawing the lines. It means these are groups. What are they? Groups. How many groups are there? Yeah. Can you count how many groups are there? 18 groups, right? How many periods? How many periods are there? 7 periods. 7 periods, 18 groups. Okay, students, can you see here some elements which are kept just below the periodic table? Here are 2 rows of elements. What are they? They are lanthanum to lutetium, and next one actinium to lawrencium. Lanthanum, see here, lanthanum to lutetium. I'm just sticking it, and actinium to lawrencium. These all elements, these 14 and 15 elements are kept in this group. See, they are kept here. And these 15 elements, they lie in this one. So they are called inner transitional elements. What do you call them?
Yes, sir.
Inner transitional elements. Now let me tell you clearly. Once give a glance upon it, students.
Yes, sir.
So these elements which I am circling,
Yes.
1A and 2A, 3A, 4A, 5A, 6A, 7A, 8A. These are representative elements. What do you call them?
Yes, sir.
Representative. Okay. Now, students,
Yes.
these elements
Which element,
which
sir?
are circled with green, did you see?
Green?
Yeah.
Only red.
You know, I have just used one green line. Did you check?
Yes, sir, that inside one?
Yeah.
Circle?
Yeah.
Yes, sir.
So these are transition elements. And
Yes, sir.
which one I'm going to circle now? So these elements are inner transitional elements. There are mainly three types of elements. The elements which are circled with red, they are representative, which are circled with green, they are transitional, which are circled with blue, they are inner transitional. Why are they inner transitional? Because they lie inside the transition elements. Okay, so let's make it clear. So that is the periodic table. Now, students, so what do? We will talk for some time, then we'll forward our lesson because our class must be interactive. Let me check what are the students doing now. Pritima, what did you write till now? Just tell me. Yeah. Not written anything? She didn't write. Okay, go on saying. Yes, say. Why is she feeling shy?
Yes,
Pritima. Oh. Jerome, you tell me what did write. Where is Jerome?
Zero.
Yeah, Jerome, your turn.
Zero, no, your turn.
Okay, Ojas, please you tell me.
Zero, BT.
Ojas,
Yes, sir.
Ojas, you tell me.
Yes, sir.
You tell me what you write.
Okay, sir.
Yeah,
The modern periodic law states
good.
the physical and the chemical properties of the elements are the periodic function of their atomic numbers,
All right.
and the chart or table that is obtained while when elements are arranged in the increasing order of their atomic number is called modern periodic table.
Okay,
And some advantages of the modern periodic table:
okay, please go on.
elements are arranged in order of increasing atomic number without changing their own places.
Good.
The isotopes of the same element have the same atomic number, therefore they find the same position in the modern periodic table.
All right.
The representative and transition elements have been separated in the modern periodic table,
Good.
and it separates the metals from non-metals.
All right. Okay, students. I hope everybody is writing. So whatever we are discussing, the matter is displayed in the screen. So you have to write immediately. Okay. So make note. That is the system. So those students who are smart in writing, they can do much better in their life. But those students who just listen and then sit without doing any work cannot do anything. So now let's see what is shared in the screen. Okay, that was discussed. Now students, this is last for today's class. Earlier we discussed that advantages of modern periodic table. Now we are discussing characteristics of modern periodic table. What is the first characteristic? Elements are arranged on the basis of their increasing atomic numbers. The element with less atomic number is kept first and others are kept slowly later on. Second characteristic, there are 7 periods and 18 groups. 18 groups in the modern periodic table. Number 3, the strong metals like alkali metals and alkaline earth metals are placed on the left side of transition elements, and non-metals are kept at the right side of and metalloids between metals and non-metals. So here you have to remember, strong metals are kept in left hand side, strong non-metals are kept in right hand side, and metalloids are kept in between metals and non-metals. Okay, students. Now next point. Uh, Inert gases like helium, neon, argon, krypton, xenon, radon, they are kept in zero group. They are kept in zero group. Uh, Somebody is talking. Who is talking now? Is somebody talking? Is somebody talking? Please don't talk. Okay, students. Now, number 5. In the modern periodic table, the elements of lanthanides and actinides series, which belong to group 3b, are kept below the main table. Why are they kept below the main table? Because they have similar physical and chemical properties. All the elements have similar chemical and physical properties. Now, next one. All the groups are divided into subgroups A and B. But 0 and 8 groups are not divided A and B. There is group 0 and group 8 only. The modern periodic table is made up of series of rectangles. Each rectangle gives us 4 important information. They are atomic number, atomic weight, name of elements, symbol of the element. So that will be discussed later on, just pointing it. And the last portion for today is differences between Mendeleev's periodic table and modern periodic table. Okay, left hand side, as usual, Mendeleev's periodic table. Right hand side, modern periodic table. So the students, look at here now. Mendeleev's periodic table contains the elements arranged in ascending order of their atomic mass, whereas in modern periodic table, elements are arranged according to atomic number. In Mendeleev's periodic table, it fails to explain the correct position of hydrogen, isotopes, and lanthanides and actinides. Modern periodic table explains the position of hydrogen, isotopes, lanthanides, and actinides. And Mendeleev's periodic table contains less number of elements. Modern periodic table contains more number of elements, 118. Mendeleev's contains only 63. It contains only 63. It contains 118. Remember. No separate place for lanthanides and actinides. Has separate place for lanthanides and actinides. And there are 8 groups. And how many groups are there? 18 groups. So these differences you have to remember, then only you can do something better. Now students,
Yes, sir.
once again we will recap, and then I will give you some work to do. So our class was based on modern periodic table, modern periodic law, right? So let me see who is in third one. Pritima. Now Pritima, you just tell me what did you write? Her turn now. Pritima Sanjel, where are you? Pritima, can you hear me? Okay, say. What was it discussed in today's class? Come on. Pritima, what happened? Karuna, can you say? Karuna, can you say what did you write?
Yes, sir.
Okay, come on.
Yes, sir.
Okay, come on.
Characteristics of modern periodic table.
Okay,
Elements are arranged on the basis of their increasing atomic number in the modern periodic table.
good.
There are 7 periods and 18 groups in the modern periodic table.
Okay,
The strong metals and alkali metal and alkaline earth metals are placed on the left side of transition elements, and non-metals are at the right side, and middle is between metal and non-metal.
good, good.
So inert gases like Na, Ne, Ar, Cr, Hn, and Rn are kept in the zero group at the extreme right side of the table.
All right.
In the modern periodic table, the elements of lanthanide and actinide series, which belong to group 3b/13, are kept below the main table in two separate rows.
Good. Okay, now Ashok, I think Ashok is ready. Ashok, can you continue afterwards?
Sir, the physical and the chemical properties of element are the periodic function of their atoms. The chart or the table that is often when the element are of their atomic number is called a periodic table. Basis on the periodic table law consist of long form of periodic table or a modern periodic table. Advantage of modern periodic table: the wrong position of some elements like argon, potassium, due to the atomic weight has been solved by arrange the element in order of increasing and number without change your own places. The element of group say 8/18 of periodic table, iron carbonate, are the place between the group I 2IA by 2 and 3M 13 as of group B. That is, the transformation, the transition of element has been separated in the periodic table.
Good. Okay, Sabbu, what did you write? Can you say? Sabbu, your turn now.
Me.
Yeah, yeah. Now you can read.
So I'll do it.
Sorry? Okay, then who is here? Sujal, can you read the differences between Mendel's periodic table and modern periodic table?
Who will read?
Sujal.
Where is Sujal?
Okay, Ojas, you can read.
Yes, sir.
Okay, Ojas, will you read?
Mendeleev's periodic table.
Okay,
Elements are arranged in the ascending order of their atomic masses.
good.
Modern periodic table. Elements are arranged in the ascending order of their atomic number.
Okay,
Mendeleev periodic table. The number of classified element is less. The number of classified element is more. There are 8 groups. There are 18 groups. They has no separate place for lanthanides and actinides. They have place for lanthanic actinides.
okay, students. So, in today's class, now we are going to sum up. In today's class, what was discussed? We have discussed modern periodic table, Mendel's periodic table differences, and in tomorrow's class, we will be discussing about groups and periods. And I hope you are going to make attractive notes, and I'm going to ask you tomorrow. Okay? So, today this much. Have a wonderful time. Bye bye.